So now we've talked about lenses and what a focal length is and a focal point, and whether it's a positive focal length, a negative focal length. Now we are going to talk about how to solve for focal length and distance mathematically. So, to find the focal length mathematically, 1 over the focal length is equal to 1 over the distance of the object plus 1 over distance of the image. So F is your focal length. DO is distance to object. And DI is your distance to image. So we have a positive lens of a focal length of 10 centimeters. An object is located 20 centimeters from the lens. So what do we know? We know we have a lens that has a focal length of 10 centimeters. It's a positive focal length. So that means it is a convex lens. We have some object located away from it. So the rays are going to travel to and then bend down to a point where they meet. Okay, so that means we are going to be doing a real image. And we want to know what this distance is. Well, we know, what do we know? We know focal length is 10 centimeters. And we know distance of the object is 20 centimeters. We know the formula. 1 over focal length equals 1 over DO plus 1 over DI. So that gives us 1 over 10 has to equal 1 over 20 plus 1 over DI. The easiest way to do this is first and foremost get rid of that decimal or the division and make them decimals. So 1 over 10 is 0.1 equals 0.05 plus 1 over DI. Then we move the 0.05 to the other side. So that gives us 0.1 minus 0.05 has to equal 1 over DI. No, 0.1 minus 0.5 equals 1 over DI. So do the math. That gives us 0.05 equals 1 over DI. So that means DI, because now we flip it, is equal to 1 over 0.05, which is 20 centimeters. Oops. So our image is 20 centimeters behind the lens on the other side for our image. Now we have a lens that has a negative focal length. So what does that mean? That means it is a diverging lens or concave. So our object, 20 centimeters out in front, so our image is right here. So what do we know? We know focal length is negative 10. We know distance of the object is 20. We need to know distance of the image is an unknown. But we do know it is a virtual image. So let's go find where the image is located. We know 1 over the focal length equals 1 over DO plus 1 over DI. We know focal length is -10. We know DO is 20. Put in the numbers and solve the math. So we get 1 over -10 has to equal 1 over 20 plus 1 over DI. Negative 0.1 has to equal 0.05 plus 1 over DI. So negative 0.1 minus 0.05 has to equal 1 over DI. So we have 0.1, negative 0.1 minus 0.05 equals 1 over DI. So that's negative 0.15 equals 1 over DI. So that means DI has to equal negative 1 divided by 0.15, which is negative 6.67 centimeters. So that means the image is on the same side as the object at 6.67 centimeters from the lens. So now we have an object that's 22 centimeters in front of the lens, or from the lens, and it produces an image 15 centimeters from the lens. What do we know about the focal length? And what do we know about the image? Well, we know the image is in a negative number, so that means the lenses have to be convex, and the image is real. So you have some object over here, and it produces an image over here. Let's find out how to do that. Going back to our formula. Our formula says 1 over the focal length equals 1 over DO plus 1 over DI. We know DO is 22 centimeters. We know DI is 15 centimeters. So we know 1 over the focal length has to be equal to 1 over 22 plus 1 over 15. Go ahead and do the division. 1 divided by 22 is 0.045 plus 0.067, which is equal to 0.112 is 1 over the focal length. So 1 over the focal length is equal to 0.112. Go ahead and flip that, so the focal length is equal to 1 divided by 0.112, which is 8.92 centimeters. So our focal length is 8.92 centimeters.